Hey y'all, welcome back to the Hack Shack. Today we've got another box from the folks at Hackerboxes. This is Hackerbox 115, and the name is Wispier. Let's get this on the bench and see what we have inside here. This looks like two of our dual band omnidirectional SMA male antennas. These are some female DuPont jumper wires. This is a IPEX right angle SMA female RF pigtail cable. This is an OLED display module, 128 by 32 pixels, and an I2C interface. This is one more of our dual band omnidirectional SMA male antennas. This looks to be a serial USB CP2102 module. This is the ATG M336H navigation satellite receiver with IPEX antenna. This is a micro SD card slot module. Here we've got two more of those IPEX right angle SMA female RF pigtail cables. Now this bag right here has several different things in it. Here's the BW16 module. Got some headers there. Got some little micro switches here. Got a temperature sensor right there. And some standoffs and screws and resistor. And this is pretty cool. This is our 4-cell 18650 lithium battery power shield. This looks pretty cool. This is an ESP32 Room 32U module with IPEX RF port. And here's another one, same thing, another ESP32 Room module. And here we've got our exclusive Wispier printed circuit board. And this is a really nice PCB. Can't wait to see how this works. And here we've got our exclusive Wardriver themed sticker sheet with some great stickers, Hackerboxes, Wiggle Nut, and a couple of cool ones from Agent there with his barcode logo and his cool script kitty. And last but not least, we've got our Hackerbox 115 collectible reference card with some BW16 pinout information on that side and some photos of the other modules in this box on the other side. Pretty nice. Before we move on, I'd like to take a moment to thank today's sponsor, PCBWay. Got a design ready? PCBWay makes it easy to bring it to life. Upload your files, pick your options, place your order. Whether you're a seasoned pro or just tinkering for fun, PCBWay delivers quality boards fast. Just like they always do, the folks from Hackerboxes have included a great set of instructions here available on Instructables. I have a link to that in the description. Even if you don't have the Hackerbox, you might find it pretty handy. So just what is this box all about? What's up with Wispier? Well, it's a reference to an earlier box back from 2023, Hackerbox number 89, which was called Wispy, or maybe Y-Spy, I don't know. It was inspired closely by the work that JHewitts had done with his Wardriver.uk project. The biggest improvement is that now it's got 5 gigahertz, and it did not have that before. And also, this new form factor is thanks to the awesome Agent with his Signal Sleuth project. And also this form factor design makes it really nice because it can package right together with a 4-cell 18650 lithium battery power shield. So that gives you a nice bit of power capacity for roaming around and collecting data. So what is Wardriving? It's basically just the act, like it says here, of looking for wireless networks and possibly GSM networks and nowadays Bluetooth devices as well. And that term Wardriving is based on ward dialing, which is an old throwback to this scene in war games where you can see Mr. Lightman uses a sequential dialer to just brute force through a bunch of numbers and a prefix to try to find his target that he's looking for.
Fish market.
Way back in the day, back before anything had a Wi-Fi built in and you had to stick a PCMCIA card in your laptop, I remember playing around with Kismet and driving around my small hometown in South Carolina and like seeing nothing. But now You know, in my driveway where I live now, it just lights up. I can probably see 30 different SSIDs, and I'm sure I can see, you know, quite a few if I go back home. But it's wild how much things have proliferated as far as Wi-Fi and other technology in the last 25 years or so. For a nice little primer on what modern wardriving is all about, check out this video from Agent that's referenced in the Instructable. I think you'll dig it. Okay, the first thing the Instructable has us do is get this BW16 module onto the board. We're going to be soldering these castellated style connections, which is a little bit different than through-hole stuff, but it's not all that bad. There's a tutorial mentioned in the Instructable that's pretty good. You can check that out if you want to get some ideas on how to do that, if you just don't want to play it by ear. Next, we're going to put the 6-pin right angle header onto the board, as you see right here, and solder that in. And I haven't said it yet, but if you've seen my videos before, you know sometimes I'll use Blu-Tack. That's what that is. I'll put a link in the description if you're interested. It's pretty handy for holding stuff in. Next, we're going to put these two SMD push buttons into place. You'll see here one on the burn marking there and one by the reset marking. And you'll see what I do a lot of times with stuff like this is I'll put a little drop of solder on one side of each of these, and then I'll heat that up and let the button kind of fall down into it, and then I'll come back around and get the other side, and then sometimes I'll come back and revisit the first side. Now there's an interesting note in here that talks about there being an extra push button, and it mentions this is coincidentally the same size button that was suggested for use in step 6 of the previous Hackerbox 114. And you'll see here, I'm going to go back and grab that board and put this button on here. It's a lot nicer than how I was demonstrating with the jumper wire, which is perfectly fine and a nice hackery way to mess around, but this little button makes it perfect. And the next thing we're going to do is break off 6 pins from the straight male pin header strip. And then we're going to solder the 6-pin header onto the serial module. Next, we're going to use the 4 female jumper wires to connect the module to the log UART of the BW16 on the Wispier PCB, like so. Alright, the next thing we have to do is configure the Arduino IDE. And in the Instructable, you can see there's a link there that it tells us to grab. And then we're going to go to File, Preferences, and in the blank for Additional Board Managers, we're going to pop that in there and hit OK. Next, we're going to go into the Board Manager and search for Realtek Amoeba boards and hit Install. And then we're going to select Tools, Board, Realtek Amoeba boards, and AI Thinker BW16. Next, you need to go to Tools, Port, and make sure you select the port that showed up when you plugged in the serial adapter to USB. Alright, so I got some stuff really goofed up here, I think. The section where it's messing with the firmware for this device, or verifying the factory firmware first, I think I got like out of order and stuff and was trying the wrong commands at the wrong time. But ultimately, you should see here in this section where I do this one AT plus GMR command and do see the firmware, and I'm assuming that's the factory firmware. And as I'm doing a little editing here, I'm not sure that I changed that. Maybe later in the video, we'll see if I did. Maybe things ended up kind of working and I had no 5 gig that I was receiving because I wasn't using that radio. So if you're following along with me, I would recommend if you get to this section in the Instructable, just lock in and make sure you don't jump around, because I evidently got goofed up with here. Just go from top to bottom, follow step by step, and you should be fine. I apologize for any inconvenience. Now, if I do need to go back and change the code on the BW16 after the other boards are populated, I think it's very important that we all pay attention to this power supply note here. It's basically saying if you have to do that, do not use the power lead that's on that serial adapter. You should power the board with one of the ESPs, USB-C, or some other way. So just be mindful of that. Okay, assuming you follow those directions better than I did and you've got the firmware updated on your BW16, the next thing the Instructable is going to have us do here is grab one of your ESP32 boards and plug it into a USB port on your PC. One quick basic check is that you should see the power LED light up here. I'm technically out of order with the Instructable here, but you should also make sure that you go into Board Manager within Arduino and search for ESP32 by Expressive Systems. And you can see here I've already got that installed because this button says update instead of install. And if it was up to date, it would just say remove. So I'm good there. If you don't have that, you should install it. All right, next we're going to switch our board by going to Tools, Board, ESP32, and pick ESP32 Dev Module. And next we're going to open up File, Example, Basics, Digital, Read Serial. And we're going to find that line where it says int push button equals 2, and we're going to change it from 2 to 0. You'll notice here that the serial port was detected the same as the BW16, so there was no need for me to change it. And then we're going to push that to the board. And after that's done, we're going to open up the serial monitor and set it to 9600 baud. Now the Instructable said I should see a steady stream of 1s, and bet it would change to 0 when I press the boot button, but that did not seem to be the case for me. So next I did some searching around, and if you look here, I'm going to change this pin mode thing here to input pull up instead of just input, and then I push that code to the device. And now you should see when I'm pressing the button down, it goes from 1 to 0 for as long as I'm holding the button down, which is what we wanted it to do. So next the Instructable says to test the other module, just take that one off and pop on the one we haven't touched yet, and we'll push that same exact code to it. And if it acts the same, it's a good test that the thing's working as expected and should be fine to use. And as you see here, it does the same exact thing as the first one did. Using the PCB markings to orient one of our ESP32 modules, the Instructable tells us to stick one of these into position A on the board and to solder it in place. Next, the Instructable tells us to put our GPS module on, and you want to orient it so that the little antenna connector is facing outward, not down towards the PCB. And I'm going to use a pair of tweezers there to kind of hold it off. And I'm soldering the top pins first there on those headers. Then I'm going to flip it over and use the tweezers again to kind of press it up. And I'm going to get these on the back. And then next, what you'll see is I'm going to trim these back a little bit because these are a little bit long. And then the Instructable tells us to feed this through the back of the board, this being the antenna for the GPS module. And you're just going to press that into the little connector there. I had a little trouble getting that, so I used some tweezers here to kind of press it, but make sure you're really aligned correctly. You don't want to mess up that connector. And next we're going to plug in our ESP32 in slot A there. And the Instructable tells us we need to get this tiny GPS Plus ESP32. So I'm going to go into the library manager in Arduino, search for that, and install it. And it also says we need this ESP software serial. So I'm going to do the same thing, look in the library manager for it, find it, and install it. And then after that's installed, I'm going to go to File Example, Tiny GPS Plus ESP32, and Device Example, and open that up. And within that, the Instructable tells us to find these two lines and change them to this. We're going to pop it in and make it 16, 17, and 9600 speed. We're going to push that to it. We're going to serial monitor. We're going to change that to 115, 200. And it should just start spitting out, long and lat. And of course, I just fired this up, and I'm in the basement here, so I tried this for a while and it never did resolve anything. Now, what I did do is grab this and I went outside and plugged it into my Linux laptop with Arduino. And you can see here after it sat outside for a little bit, it did get a fix. And I'm not gonna, give you my exact coordinates to my home here, but it did work. Okay, next the Instructable advises us to put our OLED screen onto the PCB. So you can see here I'm sticking in the headers there and a little bit of Blu-Tack to kind of hold it in place. I'm going to flip it over. Then I'm going to solder that in. Next, I place the display down on the pins that are up on the front side of the board. And I put a little bit of Blu-Tack under the edge so it's kind of laying flat. And then I solder those pins. And then I gave things a quick look to make sure that display was pretty flat. Next, the Instructable tells us to grab this Adafruit GFX library and the Adafruit SSD 1306 library. So I searched for those. In this case, I already have it installed, so I don't need to do that. If I didn't, I'd have an install button right there. Then I'm searching for this SSD 1306. I don't have that installed, so I'm going to hit the install button here, and I'm going to hit install all to make sure I get the dependencies that that module has. Next, the Instructable is telling us to open up file example Adafruit SSD 1306, SSD 1306 128 by 32 _ I²C. And the Instructable tells us to look for that line that says OX3D and change it to OX3C. But if you look down here, it's already set to OX3C in my case. So I just go ahead and push the code to it after I actually remember to plug it back up. With that code running on it, you should see a nice little Adafruit demonstration of the graphic capabilities of the little display. And as you can see, that's what we're seeing right there, and that all looks good. Now, the next thing the Instructable said to install was the next ESP32 module, but I totally missed that, and my eyes were drawn to the bold text that talked about putting in the digital temperature sensor. So that's what I'm poking in right here. That's the device that looks kind of like a transistor, and it just goes in. The orientation, you can see there's on the silk screen, it's got like a little D shape. You just want to make sure your device matches that when you push it through. And then you'll see I'll just kind of bend the legs back a little bit on the back side and solder those pins. Next, we take the single resistor that's included in this Hackerbox, and we're going to install it right here where the resistor picture is on the silk screen, and then solder it into place and clip the leads. Next, the Instructable advises us to look in the library manager and search for the one-wire library. And you can see here, I find that, and then I click install and get that going. Now, this is about the time when I realized I skipped installing the second ESP32. So I took a moment and corrected that by popping that into the board and soldering it into place. After I got that soldered in, I got back on track and opened up file example one wire ds18 by 20 _ temperature.ino. And then on line 10, we changed the one wire ds10 to 22 to match where our temperature sensor is on this one. We have to make sure we connect up ESP32B, and that's where we're going to push the code to. After that, we're going to go into Tools, Serial Monitor, set the speed to 9600 baud, and you should see about every second or so the temperature reading from that sensor. Next, the Instructable has us put the micro SD card slot module on here, and you want to orient it so with the headers, you've got the metal part of the SD card slot facing against the PCB. You can see I tack in one pin there to hold it, and then I'm going to flip it over and catch the others. Next, I positioned all three of the RF pigtails onto the board as specified and soldered all their pins. In the past, on some RF connections, you may have seen me use a dab of flux, I didn't do that this time, and I still think it turned out okay. Next, I got a little bit out of order again with the Instructable and went ahead and stuck my antennas on. And then I put the small ends of the cables of the pigtails through the circular opening in the PCB and landed one of them on the BW16 and 2 of the others on each of the separate ESP32 module connectors. And now we're directed to head over to JHewitts GitHub, and I'm going to grab the A sketch and the B sketch out of the respective folders there. And then I'm going to grab these 2 libraries. I'm going to search for them. The micro NMEA, I'm going to find that and install that. Then I'm going to look for the gparser library and install that. And as you might have guessed, the A sketch goes on the A ESP32. And the B one goes on the B ESP32. But then I got this error that you see here. In hindsight now, I wonder if that's because of the firmware not actually getting updated on the BW16, and that's why that gave me this particular error right here. Not quite sure, but that's my hunch. Now, for better or for worse, I just goofed around and modified this line right here and gave it another shot, but knowing full well that this probably isn't how it was supposed to be working. And I thought this was going to compile, and it almost did until I got this. Oh, I got the exceeds available space on the board. Then I realized I probably rushed ahead and missed some other documentation and settings that I was supposed to have, so I went and looked for those. I found these recommended settings on the JHewitts GitHub, and I went through all of my settings and tried to make sure they matched up, and then I tried to send the code again. And this time it worked with no problem. And the Instructable tells us to create a file called cfg.txt on the root of our SD card we're going to use. I couldn't find a blank one, but I grabbed this one I had for some Apple II emulation and created a cfg.txt. And within that, it tells us to make this SB_BW16 equals yes. And then we'll power it off here, and I'll stick the SD card in there, and then we'll fire it back up and see what it does. And it eventually comes up and gives you the information. We can try to connect to it with your phone or whatever. It's kind of like in hotspot mode, and you can do all these other settings and like interact with it directly. But what I did basically was like told it to just be almost standalone and just do its thing and essentially just dump it to the SD card. And that's the mode I've been playing with it so far. So I don't really have anything to show you with messing with the web interface much at this point. But you can see right here, it's definitely picking up some stuff. But I wonder if it's actually really picking up any 5 gig stuff based on hindsight here. Maybe it did, but maybe it's just not able to identify that certain WPA if it's present or not. All right, so the next thing we're going to be working on is this battery shield. And I'm just going to let you see this image from the Instructable. We're basically going to have to be messing with some standoffs and screws to hold them together. There's one on each corner, so 4 sets of those all together. And then we've got this little connector. We're going to have one female side that's on the battery shield side, and we're going to have these 2 pins that are going to be on the back side of the actual board itself, the board with all the logic and everything. And that's going to plug into that, and then the standoffs are going to kind of hold it together. So that's essentially what you're going to see me doing here in the next little bit. And the Instructable advises us to trim down these pins that are sticking out of the back of the USB port that's on the top of the shield. So I kind of trim those close as I can to the board there. And here you can see I've got the battery shield side of the screw and standoffs ready to go. And this is when I decided to take a little bit of Blu-Tack and spread it out just as a little extra protection and insurance over those pins And now here you're going to see this is the male pin for the main board side. And then I've got the female side that's going to go right here on the battery shield. And I'm going to just kind of hold that in place. And I'm going to go ahead and stick this header in here. And then I'm going to go ahead and sandwich the boards together. And after I do that, then I'm going to solder on both ends to hold those in place. Now the Hackerbox doesn't come with any 18650s, and I don't have any, so I ordered these up from Amazon. They feel a little lighter than I think they should be, but I haven't done any kind of conclusive charge quality measurements or anything like that on them. And it came with 6 batteries and this little charger, and you know, each battery's got this plastic covering, so I use a pick and got that off of there. And I just hope it goes without saying, like, lithium is or has the ability to become pretty dangerous if you make some mistakes or short something out. So just please exercise a lot of caution when you're messing with these lithium batteries. Now, please note when you're loading multiple batteries in here, look, they don't zigzag. They're all going to be oriented the same way. And technically it'll run off of 1, 2, or 3, or all 4, but just make sure you've got them all going the same way polarity wise. And then I hit the white button on the shield and it booted on up. That's pretty cool. Nice little high capacity battery powered Wardriving thing here. And you know, I can't leave well enough alone. The Instructable said that the Signal Sleuth case from Agent would actually fit this pretty well. So I found that and printed it out. These are the colors I chose, and it's basically 3 pieces like this. I initially tried to see if I could use the fasteners that came with the Hackerbox to get it together, but I realized that would definitely not work. So I grabbed this little assortment of hex screws I got from Amazon a while back, and then I was able to assemble it. And here's the end result of what it looks like all put together. All right, as we've discovered together when I've been editing this video, it appears that I totally missed flashing the BW16 to that open firmware. So I wanted to take a moment right here as I'm editing and walk back over to the bench and hook things up to the case. And I will say, this was kind of a pain. I would probably advise just taking the thing out of the case so you can easily access those burn and reboot buttons and stuff, because this kind of was a little frustrating at times. But anyway, I hooked it up in that first mode, like for flashing the code, like we did earlier. And remember that power warning from earlier that we had in the Instructable. Anything else we do after we build the rest of the board out, we no longer want to hook up that 3-volt line when we're using the serial adapter to mess with the BW16. And because of that, we'll supply power like this, so it has plenty and it's not trying to power the whole thing over that USB port through that serial adapter. And then I went back and I grabbed that BW16 firmware and I opened it up in Arduino and sent it over the serial interface. And when it gets to this point is when you're supposed to do the little trick and hold down boot and then hit reset and let go of boot, and it'll take the code. Now, if you've looked at the Instructable, you realize that to try out the BW16 Open AT interface, we have to move some serial lines around. And so that's what I'm doing here. And remember, again, just like I just said, we're not going to hook up the 3-volt line from the USB to serial adapter. We're going to leave that disconnected, but we're going to change what RX and TX ports that we connect to. And we're going to set the serial baud rate to 38.4 in the serial monitor inside Arduino. And you can see right here, when I switched over to the serial monitor, I can actually see the little BW16 open boot message there. Now, one thing I think happens, since I can't turn off the other ESPs, it'll become non-responsive on that console once the other system starts booting up. But I was able to like type that ADAT command and, you know, got this.
Use your harpoons and tow cables. Go for the legs. It might be our only chance of stopping them.
And later I did the TWS and it actually did the scan. So I think that was a good indicator that the firmware was finally upgraded. So that was cool. I drove around in the car with my wife. We were running some errands and let this thing run. And you can see it captured all kind of junk. And I left it parked with it running too. And it picked up a bunch of APs. It picked up a bunch of BLE stuff. So it's pretty darn cool. Now, I didn't use the mode, where you can connect to it as an AP. Now, when it first boots up, it'll let you, connect to it like an AP and you can make some decisions. I chose to not let it do any kind of wireless stuff as far as connecting to my network. And I've just got it running and I can just pull the SD card out and look at that if I want to and upload that to wickle.net. But I'll leave that as an exercise to you. If you could build this thing, I'm sure you can figure that out. And this was a fun one. I think you'll enjoy it too if you give it a shot. It looks like we're going to have ourselves another giveaway. The nice folks at HackerBoxes have graciously offered to send a HackerBox 115 to a randomly picked commenter. We'll be picking the comment on September 7th, 2025. And remember, HackerBoxes only ships to US addresses for this giveaway. So if your comment's picked, but you don't have a US shipping address that we can use, we'll need to pick someone else. Good luck. At the time of this recording, there are a few HackerBox 115 still in stock, but I've been told that quantity is very limited. And a little bird also told me, if you're into Wardriving but missed this one, you might want to go ahead and subscribe because there may be something right up your alley coming with the HackerBox 119 release. Hey, if you made it this far, thanks for watching. Hope to see you again next time. Take care. Bye-bye.